The last topic we want to talk about that's related to types and arguments in Scala is that of multi-dimensional arrays. And this could also be multi-dimensional lists, though multi-dimensional lists are probably less common than multi-dimensional arrays. As the name implies, this would be an array that has 2 dimensions or 3 dimensions to it. And the way that's implemented in Scala is just to make an array of arrays. There's kind of nothing all that special to it. So we've seen that when you make an array, it has a type for its contents. So this, for example, is an array of int. Well, what goes inside of here can be any type that you want, including another array type. So we can make an array of arrays of ints, and that would be a 2-dimensional array. Or we could make an array of arrays of ints, which would be a 3-dimensional array. How can we declare that? Well, we just make an array, and the contents are arrays. Something like that. So this is now a 2-dimensional array. How about we give it a name? So 2D has, you could think of it as a first row of 1, 2, 3 and a second row of 4, 5, 6. Because of how these are stored, this is rectangular. It doesn't have to be. You can have what are called jagged arrays, where we have different lengths for each of the subarrays. How do we get into these things? Well, so the type, TWO, of the whole thing is an array of ints if I index into it. So sub0 should give me the first set of contents, which is just an array of ints. And then I can index into that, and so getting the sub1 here gives me back the 2. So when I have a 2-dimensional array, I specify my 2 different indices in much the same way as I would a curried function. And it turns out that arrays and lists in the indexing are just functions. There's just a function application. I'm applying 0 to this array, and that gives me back another array, and then I'm applying 1 to that, which gives me back this int here. So it's much like a curried application. I do each in turn. Note it is not, I stress, not like that. That doesn't have any meaning to Scala. Then it thinks it wants a single argument list with those values. So you have to do the 2 values separately. Now this syntax is fine for making little arrays, but we often want to make big arrays. How can we do that? Well, to make big 1-dimensional arrays, we used fill and tabulate. We can do the exact same thing here. Array.fill. If the first argument list is given multiple arguments, so say 3, 5, and I'm just going to make an array of zeros, this will be a 2-dimensional array with 3 rows and 5 columns. So there are 3 arrays inside of here, and each of those subarrays has 5 elements inside of it, and they all are set to 0. I can also do this with tabulate. So I can make myself a nice little multiplication table. Now here, my function has to take 2 arguments because there are 2 indices, the row index and the column index. And so there we get a little multiplication table. When it's 0 times anything, we get all zeros, and the next one is 1, 2, 3, 4, 5, 7, 8, 9, and then multiples of 2, and then multiples of 3, and multiples of 4. Yay, we have a multiplication table that we could make with tabulate as a 2-dimensional array. And of course we can get into this thing. If I wanted to know what 7 times 6 is, I can look up in there and hey, I get the value 42. So this kind of introduces the basic concept of a 2-dimensional array. As I said, you can do this with lists. It's probably not as common, but the syntax works just as well. There's no problem with it. The applications for these things would be for storing grids of information. Turns out that images are often processed as arrays of arrays. We'll be doing examples later on where we're making mazes, and that maze will be a grid, and we'll use an array to store the values for that. So kind of anything that is tabular data or a matrix is a very good example of a two-dimensional array. Those would be the applications where you want to use this inside of your code. They're really not all that complex. Just remember that each level of the parentheses that you use is kind of peeling off one array, and so if you want to get to an actual value, you have to have as many of these as you do dimensions in the array.